I'll do a screencast so the guys who are over in the other sessions can watch it afterwards. That's no, you can go. But it's 60 minutes, so it's a long. Nobody will watch it over the net. Anyway, so who wants to see the guts, or only, who wants to see only the overview? Who wants to take over if I'm get hit by a truck?
I need to sleep, so I'll look at the guts.
I'm searching for one who takes over if I die.
I volunteer, yeah.
Okay, two. Okay, so I'm doing only the simple stuff. I have a newbie version and I have a technical version. The newbie version is strictly the slides. The technical version is then the shell, Emacs, compiler, pictures, and so on. We will see. I'm happy to be here at my first Perl conference. Normally I'm only at Lisp conferences and sometimes Wiki and PHP and Python.
Evil.
And I met Patrick Michaud at the Wiki and PHP conference first. We are competing Wiki authors. He is author of the PM Wiki, I'm author of the PHP Wiki. So that's how we met, but we're both doing the compilers. He's doing the Perl 6 compiler, I'm doing the Perl 5 compiler. It's interesting. Yeah, but I'm also working with Parrot. I stopped working with Parrot, but I did work for Parrot and Perl 6, and I'm doing the packages for Cygwin. So, whoever knew the compiler before, this is new. I fixed all bugs, but when I wrote this, somebody came up with new bugs, so there are always bugs. When I wrote this was, I think, in February. Before we had 12 bugs in the bytecode compiler. I'll explain later what it is. We had 6 serious bugs in the C compiler. Now we have only 1, and in the optimizing C compiler, that's not C++, that's just an optimizing C compiler. 9 bugs, I got rid of most of them, but there are still some left, so you have something to do because they are so easy to fix. No, they're really hard to fix, but if you want to, you can fix it by yourself. 5.14 is not ready yet. There are some problems with CVs because some weeks ago I decided to rewrite CVs and I broke it. So yeah, I tried to rewrite because 5.15 didn't work, but I broke all the other versions also. So I have different versions around, but it still doesn't work. But no big headaches. The biggest changes what I did to the compiler. The compiler existed for ages, for about 10, 15 years. I'm with Perl since Perl 4, since about 20 years. But I never knew Malcolm Beatty who wrote it. And I only wrote to him once per email. I think he's an Oxford guy, and I was in Cambridge, so no idea who he is. I changed the header format, so the PLC format, old guys probably know it, that's the compiled, bytecode compiled format, so if you load a module, you can have a module PMC, or if you load the Perl, you can have it named PMC or PLC, and require loads this compiled version. This is now platform compatible and almost version compatible. That means if a new Perl loads an old bytecode, it should work. If an old Perl loads a new bytecode, it will not work with the new bytecodes because I have no translators. With Parrot it's about the same because I was in the design team for the Parrot PBC format. But then I stopped working for them because they stopped supporting these platform changes and version changes. Then what's new? There was no test suite. I added a test suite. Then I did some optimizations. I added an extra module to have some extra flags and extra libs. And there was some bloat. Okay. That's me. That's the history. Was it too fast? Written 95 to 97 and then never touched. P5P did some changes over the years, but only minor changes because it basically worked. And some guy, Adrian Enache or something, I don't know, wrote some more test suites for the bytecode compiler. Then 2007, Niklas removed it from core. I got angry and I started working on it. And in December, on the 20th birthday of Perl, I announced that it works. So there was this was the stage last year in December that it had 0 bugs. But then people came up, tested it, and came with bugs, so it's not bug-free. What's the problem? Biggest problem for me is magic, because I don't really want to support it, and all the known magic bugs are only with threaded variables. So some threaded subs or threaded scalars are marked with some magic, and it's not supported yet. If someone wants it, you can easily add it. Tie is dynamic. We support it, but I hate it. But this is a technical problem. Eval require foo. This loads a module at runtime, and the compiler doesn't really know which module is added at runtime. And I don't yet pass, or I let pass this require statement and get all the modules, because require imports an external module, it adds subroutines, and these subroutines get called, and the compiled code doesn't know what it is. That's the problem. So there are some tricks to get the compiler known which packages are added at runtime, but no technical problem. Everybody can work with it. So what is the compiler? The big advantage, or why do you want to use it? First, biggest, it's much faster, significantly faster. With big projects, about 20 times faster, or 30 times. I have numbers then later. The shorter the code, the less. It's about in microseconds, but then I'll show you why it's faster. Then with fcoc, it's the typical compiler optimization flag. Coc is copy on grow. Strings are allocated statically and sometimes also as const. So in a different segment, that's loaded by the kernel immediately. So it's not mallocked at runtime. And if someone wants to change this string, it's re-allocated automatically by the system, not by me, by Perl. So Perl has this copy on grow feature. If someone wants to extend this string, take this const string and move it over to the heap and extend it over there. And then I have a new feature, brand new, about 1 week. No destruct. I decided to get rid of destruction also, not of initialization, so I want to get rid of the destruction to walk through all the op tree and all the data, all the SVs and AVs and HVs, and do the free over there. It's not needed. I don't need to free the memory. System does it automatically. So it leads to less destruction time, but it doesn't really work yet. It works, but it gives me an error number, error code 159 or something like that. So for CGIs, and that's the primary usage, it's not really good yet. It also reduces memory usage. There are also some switches, about 20%, normally about 9% less memory, but it can go 20 or much less. Then the biggest advantage before was distribute binary versions only for companies. There exist packages which call themselves compilers, but they're not compilers. They have slower startup time. You know, Perl to exe, Perl up, par. They pack it everything together, then at start they unpack it and then jump into it. That's simple. Our Perl CC stuff is true compilation. And with CC, that's improved runtime also. Normally it's only startup time and destruction time, but with CC it's completely optimized. We have 3 different compilers in the suite. Everything runs under BC, because it's just much simpler to maintain this stuff. Bytecode and byteloader is completely different, but has the same compiler techniques. Bytecode is the compiler, byteload is the interpreter. It does essentially a freeze at some level, and then when you call the compiled code, it does a thaw. But much better, of course. But essentially, it's a free thaw, but much faster. And the frozen state of the bytecode compiled is PLC, PMC. PMC are compiled modules, but compiled scripts. PMCs are not supported yet, but it shouldn't be that hard to support that. BC just freezes and thaws to C, and BCC, it's completely different. That's a true compilation. I'll show you the difference later. What does the stages? Perl is used to parse it. Parse is done in token and op. Then the compiler hooks in, gets this state of the parsing tree, the op tree, dumps it, freezes it, and then Perl jumps in again and walks this code. So the compiler only does here the step in the middle. Everything else is done by the Perl runtime itself, so the compiler is really simple. You just have to understand how to store it, and to freeze it, we don't have to do the freeze. Perl does the freeze for us. That's the op walker. Walk the ops or just run the ops. It's the run loop. So the advantage of the compiler is just it eliminates the parsing time and especially dynamic allocation time. As we will see, dynamic allocation, it's all the malloc calls. That's the thaw state, the walker. This is in 1C in Perl core. There are different versions for debugging. There's a slow run-ups and so on. And this was the state at about 5.12, 5.10 from 5.6.2 or 5.5 on. Diva is essentially not needed. It's only with global interpreter stuff. Every op has the address, but the address, it's not absolute. It's just an index into an array in some opcode H, a header file. And the macro expands it. So we need to get the address of, or the name of the function from this macro. And every op is a basic bytecode inside the Perl compiled op tree. Okay, maybe you will understand it later. Returns the address of the next op. So we call a op, and each op gives us back the address of the next op. It's a chained link, a simply linked list. RTX, this is just for threading stuff. If it's threaded, the interpreter is passed here. And async check, this was the big trouble I had with the run loop in Perl, was removed by Nick. Is it here? Is he here? No. Ah, Nick is here. Nick, you are a genius. No, because I wanted to get rid of this since years, but I didn't know where to put it, and I tried. And he knows I/O and all this concurrency stuff. I don't know. And it was used in every op. So. But we have 250 or 300 types of ops, and it was moved to only about 20 ops. So it's only one we need it. And this async check just checks if there's a pending signal. If there's a pending signal, just do the stuff from the signal and then go on. It's really simple, but I'm too stupid for it. So that's why 5.15 is much faster. There's also some stuff, but I think that's the main reason why 5.15 is faster. Nick, different opinion? 5.13. I call 5.13 5.15. Is it better?
Well, it thinks it's called 5.13.
5.13. Okay. Yeah. Of course, it's 5.13 because we don't have 5.15 yet. But 5.15 will be the true fast best version ever, like 5.6 we had before. Every version got slower, but now we are fast again. So the observation, what I told you before, it's now written here in the slide. The op tree is no tree, it's a simply linked list. Every op returns the address of the next op. So the whole syntax tree, every program is a typically syntax tree. So everyone who wants to wrote a compiler and every Lisp programmer wrote a compiler because it's basic stuff for a Lisp programmer. Just walks this tree. Lisp is a tree. Walks this tree, you do some optimizations, performances, move something. In Perl, it's much simpler. We only have a linked list. So all the magic is done by Larry in the parser. Yeah, that's really magic. But the big problem is we have a macro here. We don't have the absolute address, and it's not cacheable. And of course, Perl async check was called after every single op with the optimized compiler. I give this same advantage to the old versions also. So this was the basics. What I'm talking is for advanced stuff. If you just read stuff, you can understand it. What I say, you will not understand for 80%. But just for the advanced hackers, I tell a lot because I have a lot of time. The phases, that's the most important slide to understand what does the compiler and what you need for the use. I dissect how Perl runs because I essentially want to explain you how Perl is, what Perl is doing with your script and with your modules. Because the compiling stuff is just a little bit of it. Perl first parses and compiles it to this linked list of ops, the so-called op tree, but it should be called op list. There's an op tree for every sub. Subroutine is a function. And subs got imported from packages. Packages are in files. And, there are certain stages. Begin, check, init, and some other weird stuff. But the most important stuff is begin is automatic, implicitly done by a use statement. Every use does puts a require into the begin block and the import into the init block. So you have the import at runtime and the get the file, search it, and import it, and find all the functions and declare it, and declare all the symbols at begin time. The check stuff was only done for the compiler and for -c to check it. You normally does Perl CV. Does it pass? Do you have a syntax error? The O modules just start with at the check stage. So I'm running at the check stage. You are running at the init stage. What we both do is we do the begin and the end. What I get rid of the begin stuff because everything which is a begin is in my op tree, in my heap. I dump it statically and it's frozen. The check stuff is just for me to hook into it. The init phase is then the runtime. This is slow. Everything I want to improve, I move it from the init upwards so I can freeze it. And the cleanup, unfortunately I have to clean up some stuff, but normally I don't really have to clean up because a free is done implicitly. Only if you have some shared module, if Perl runs inside mod Perl, for example, inside Apache. If it's long running, you don't care if it grows because Perl always grows. Perl never does a free while running. You probably know that. So we are running a check. We do the freeze in check, and everything which is after this freeze step is done in Perl. It's not done in the compiler. It's done in the one loop. That are the typical command lines. I compile a program with M is module, O is start the C compiler in the check block. With these options, output the file myproc, and the program is some stuff. And CC harness is the linker, or the compiler and linker. It just calls the flags from the Perl you ran it with. It's the CC flags and the LD flags. So it gets the flags from the Perl you need. So all the C flags and all the linker flags. Takes your program and outputs a binary and then run the binary. So essentially, you are compiling here with O at the check state, and then the program just runs the run loop in Perl. But the optimizing compiler gets rid of this run loop because this is stupid. When you have the whole op tree, the whole syntax tree, all the ops, and have to rely to wait for every op to return the next op, it can't be cached in the CPU. And also we don't know the address, the name of this, because we came up with this macro because there are duplicate functions for different ops. we have grep and map share the same function but have different names, and if called with a different name, it behaves differently. That's we have this indirection here. The optimized compiler emits this stuff. This is really simple. First, it gets the address of this op. That's the first op. Then it calls the op. Then it does the check if it has to. With the new version, it doesn't have to. Then it calls next state. Typically, at the beginning of every program is enter. Put everything into a block. And next state, it's a cop, and cops are normally not needed, just to store some context information, but most of the cops are not context information, they're just debugging information, file number, file line. And so, of course, we have an optimization, get rid of unneeded cops, so we don't have introspection, because introspection makes it big and fat and slow. But with the lowest, with the least optimization levels, it behaves as normal Perl. So next state only does 3 calls: taint not, then store the stack pointer, and free some temps. This is essentially how this little program print A works. You don't really have to understand it, but it's just push the current pad onto the stack. Okay. Perl has 2 different kinds of variables. You probably know my and local. My variables are lexically scoped, so they have to be carried around for functions. Functions have to access a certain area of lexicals on a special stack. That's the carpet. How do you spell it? Carpet. I'm German, I'm terrible. Carpet? Current pad, carpet. Carpet. So that's the first. Carpet. Cur is good. Carpet.
6 C is K.
And we have also 2 different kinds of lexicals. We have named and unnamed. We have carpet symbols and carpet names. Anyway, this pushes this unnamed, or this named, I don't know from here because I have to look into the pad, onto the stack, because every variable has to be put on the stack for the op, because every op takes its argument from the stack. Should I do the advanced stuff here? Okay, Perl is stupid. Is Larry here? He designed it this way. Every single language normally puts its lexicals and its arguments onto the stack. Perl does it on the heap. And probably because of recursion issues, but every serious language doesn't care for recursions above 2,000 levels, and then it should just die, or 10,000, and the stack is big enough. Normally we compile, at least for example, with a stack base. And you have a stack, and the stack is automatically cleaned up. The problem is maintaining it on a heap, okay. But then maintaining it at the end also, again, and free it costs time. And then it's so complicated what we do, really complicated. But it's written this way, okay. It's interesting. Okay, it is safe. Maybe Java should have done it this way. We are safe, but we are slow. And it's okay. He invented everything again on the heap. Okay. And it makes guts unreadable. Because what every other language does with this lexical management and stack stuff, we do in our arrays and have. Okay, put back print sp again. That's a normal function call, and the function call which takes arguments has to be put into those macros because it has to deal with our stack. Okay, but the trick here, it's unrolled. So the advantage is we don't use an indirect call by call f pointer, we call by ref, we call the function directly. It can be optimized to hell. Static direct function call. We know the number the CPU can prefetch into its cache. The CPU takes the next 30 assemblies normally and prefetches it. And only if some disruptions happen, and disruptions are normally call far or jumps. And in our code, we only have call fars and jumps. That's incredibly slow. So we can make it at least 10 to 20 times faster if we unroll it. But it's only possible with JIT. But I will not show JIT only if I have enough time. I have JIT here also. Unneeded stack handling. Yeah, the optimizing compiler does as much as it knows with the stack. So we inline most simple function calls and check the ops or the functions if it needs an argument. If it needs an argument, it tries to handle the stack before, and if it doesn't need the argument, it doesn't need a return value. It just leaves out the stack handling. For example, here I need the stack, but over here I don't need the stack, and so on.